Hello everyone. Today we will study about the topic fluid dynamics. Okay, I'm Annu Yadav from the group number 316. We further proceed, okay? So today we will talk about the flow of the viscous fluid in the tubes. Okay? The if we study in this topic the laminar flow of the viscous fluids that is characterized by the Navier-Stokes equation, and the flow is characterized by smooth and orderly motion. The key features of this flow is steady flow, laminar flow, flow profile. Okay, the velocity of the fluid at the given point does not change in this flow with the time. Laminar flow shows the parallel layers with the minimal mixing in between them. The flow is very smooth and predictable and opposed to the turbulent flow. It does not have any very disturbing behavior. The laminar flow velocity profile across the tube's cross section is parabolic with the highest velocity. Its laminar flow is determined in a circular motion, and the velocity profile is given by the Hessian-Pauli equation. Okay, in this Hagen-Pauli equation we determine the flow rate of the uh, pipe fluid in the pipe. Okay, the q is the flow rate, r is the radius of the tube, f is the mm, mu is the fluid viscosity, and r is the radius of the tube. Okay, L is the length of the tube. In this q is proportional to the fourth power of the radius, which means the small changes in the radius have a large impact in the flow rate of the uh, mm, uh, fluid. Okay, the flow rate is also inversely proportional to the length of the tube and the viscosity of the fluid. The flow rate increases with the pressure difference, and the relationship with the velocity of the fluid is for the steady laminar flow is the velocity equals to pressure difference um, uh, upon 4 in mu L into r square minus small r square. Okay, in this the v is the velocity and p is the pressure difference, and r v is the velocity at a distance r from the center of the pipe. R is the radial distance from the center of the pipe, and big r is the radius of the pipe. Okay, at center of this r0, the velocity is maximum. It decreases to 0 to the tube of the vase, that is r equals to small r equals to big R. So due to the no slip condition at the boundary, the laminar flow is typically observed at low rates with the viscosity of the high fluid. In the pipes where the Reynolds number is below the critical threshold, that is r is small than 2000, then the flow is the laminar flow. Okay, the Reynolds numbers is the dimensional quantity that helps to predict the whether the flow is turbulent or the laminar. The Reynolds number is determined by the mu into v into d upon mu. Here the here is density of the fluid into the velocity of the average fluid of the fluid, and the d is the diameter of the tube, and mu is the dynamic viscosity. When the real number is greater than 2000, then the the fluid flow is become the turbulent. Okay, in this turbulent flow, when the it is irregular, and it has swirls, and it is very chocolate, very disturbing, and this type of flow is characterized by high velocity and the low viscosity. It is observed at high flow rates and with the low viscosity of the fluid. The high real numbers is the real number is higher than 2000 is typically the flow determination is very turbulent. Velocity profile is turbulent to the laminar flow increase the losses of the in this turbulent flow there is energy loss also, and the flow resistance is that the relationship between the pressure drop and the flow rate becomes non-linear. So we saw that the flow resistance is also taking place. Okay, now the pulsatile flow is refers to the flow varies with periodically with time and is oscillatory in nature, typically sinusoidal or cyclic pattern. This flow is very often seen in systems in periodic driving force and pressure variations such as blood circulation in the heart pumps and all that. Okay, and the pulsatile flow is oscillatory, and oscillatory changes are seen in the velocity and pressure. It can be laminar or the turbulent depending on the conditions. Okay, so revise this topic, and we will see further in next classes. Okay, bye bye, have a nice day.